solutions. So what is the topic is the solution or solutions is nothing but the solution is the way of reaching of the answer. What is the answer is nothing but answer is the unique one, but the solution is the way of way. The solution is the way of answer, the reaching of the answer by using certain methods. That's why the topic is the solutions. But we can use the solution only like as a true solution, the aqueous solution, the non-aqueous solution. But the topic is the solutions. But what is the meaning of the solutions is nothing but a homogeneous mixture of two or more components or substances whose component or composition vary within certain limits. That certain limits is known as solution, that is known as the true solution. What is the certain limits is nothing but already we know that the solution is nothing but we have to be reaching the answer by using certain methods. That methods is known as the solution. So solution is equal to the solute plus is the solvent. The solute is the less amount in a solution, that is called a solute. The solvent is nothing but there's a large amount or large quantity or large proportion in that solution is known as the solvent. So like by example is nothing but we can take as a normal example, that is the seawater or is a salt water. So in a salt water, so we have to take only H2O plus and NaCl. So in a H2O can be acted as a solvent, that is a large proportion like this. So NaCl is a very less quantity, that is a small proportion, that is known as the solute. But in a seawater, so in a solution having the only two components, that is known as the it means the two binary solution. But we take the trinary solution, that means in a solution having the three components, that is known as the trinary solution, the quaternary solution, the poly solution. In a seawater, like in a seawater, NaCl, KCl, AgCl, MGBr, so all are remaining different components are there in a plus along with H2O also. So this is the small quantity solute. So this is also solute, this is also this is the large quantity, that is known as the solvent. That is known as the solvent. So like this, but in a solution we can take always as the only one solvent, but remaining all are the solute only. So in a solution containing the large number of solutes, but only the one is the solvent. That is known as this type of solution is known as the poly solutions, like as the quaternary solutions. But is in a binary solution, in a solution containing only one is the solute and the another one is the solvent. So that is called, in you take as a binary solution, trinary solutions, the quaternary solutions. In all solutions having the only one solvent and remaining all are the solutes only. So that is called a solution. We can take the only homogeneous mixture. If we take the heterogeneous mixture, that is not a solution, that is a collide. So it is not a true solution, it is not a solution. The homogeneous mixture we cannot separate by using the filter paper also. So that is known as the solutions. So can take the characteristics of the solutions. Then we after go different types of solutions, like basing on their solvent, basing on their physical state, like this. Characteristics of solution. What is the characteristics of the solution is nothing but the solution must be homogeneous. The solution must be homogeneous. Next, the solution cannot be separated by cannot be separated by filtration. Next one. In a solution is equal to solute plus, because of it is a lesser quantity, and this is known as a solvent. This solute can be separated by crystallization. This crystallization can be used in the sugar solution, separation of the sugar solution like this, and it can be separated by if the solution containing as a non-volatile solute, if the solute containing a non-volatile solute like as oil in water like this, petrol like this, if the non-volatile solute can be separated by evaporation, and one is the distillation, and like this absorption, like different types of concept by using. But the solution is having the both solute and solvent. If the solute maybe it can be a soluble, the solute cannot be non-volatile solute. Also correct. Can you? Now, different types of solutions like this. Best example, but this solution topic, it is applicable for in our daily life. We can use more and more. But best example, solution, different types of. Example, gas in gas. Next, liquids in liquids. Next one, solids in solids. So meaning of this, gas in a gas. Gas in a gas is nothing but, so this is a solute and this is the solvent. So the solute can be denoted as a dispersion phase, and it is known as a dispersion medium. Solvent can be known as the dispersion medium because of its large proportion. So next, in a liquids, so that is called a liquid is a solute and that is liquid is a solvent. One example, take an example is a brass or gold. Best example is a gold. Gold is a mixture of both Rm and copper. Take is the 24 carats of the gold. So aluminum can be used as a 22 carats, and the remaining 2 carats as the copper. Because of all metals are the malleable property, when we have to add the another metal like as a copper is added to the Rm, so the Rm can be behaves as a ductile nature, it will be hardening like this. So these impurities can be added to the gold, so the nature of the malleable property can be converted into the hardening and hard like as a hardening nature. So that's why the copper, so this is called, it is acts as a solvent and it can be acts as a solute. So that is a gold. Not only gold, remaining all also like as a brass and bronze and like remaining all alloys. All alloys are in the gas in a gas, but it is a homogeneous mixture, is not a heterogeneous mixture. Because of it can be separated, the Rm and copper can be separated by using certain methods, not by the filtration property. So already I said that in a definition. The homogeneous mixture, not a heterogeneous mixture. The homogeneous mixture of 2 or more components whose components can be vary within the certain limits by using the some evaporation, filtration, crystallization, by using certain methods only. That property is known as a solution. So the topic is the solution. So that is a sorry, it is not in a gas in a gas. So this is called as a solid in a solid. Sorry. Solid in a solid. Next, you can use the gas in a gas. Next, we will go through the liquids in a liquids. Like liquids in a liquids is nothing but alcohol in a water, like alcohol plus water. So in a alcohol and it can be acts as a solute and water can be acts as a solvent. So that is a liquids and a liquid. So this is called a dispersion phase and this is the dispersion medium. So next is the gas in a gas. Gas in a gas is a best example is nothing but air. In a air composition is nothing but N2 plus O2 plus CO2 plus argon and the remaining all gases. So in a nitrogen can be composition is a 78%, this is a 20%. So it can be acts as a solvent, but it is a solute and the remaining all are the solutes. I'm already said that in a solution they have only one solvent and the remaining all are they can be acts as a solutes only because of it all are having the smaller composition. So this is called gas in a gas. So this is a solid in a solid because of all are the metals and this is the solids and a solids, and this is a liquids in a liquids that is called as alcohol and water. So in alcohol, so this is called as a can be acts as a solute and water can be acts as a solvent. So this is the different types of solution, not only solid in a solid in a gas, that is in a camphor. So the camphor is a maximum, it is 100%, it's a gas. Under high pressure condition it can be converted as a solid. So then we have to burn in the camphor, it can be completely converted into the gaseous state because of it is a gaseous state only. Like I say, liquid petroleum gas, like that, all liquids under high pressure conditions, that is one of the properties of these solutions. Like we have to take how much amount of the solutes and solvents present in a solution. So like this, but the pressure cannot be applicable in the solids, so leave it that one. So because of not only different types of solution, remaining all of the solids in a liquid, solids in a gases, solids in a liquid, liquids in a solids, liquids in a gases. So remaining like as a soda water, so camphor. Next one it is liquids in a liquids like alcohol and water, remaining all conditions in a moisture also. So gas in a liquids, different type. We have 9 types of the different types of the solutions based on their physical state of the components. Next, by using the solvent, based on their solvent, based on their solvents, the solution may be defined as the 2 types, that is called aqueous solution and non-aqueous solution. Aqueous solution and non-aqueous solution. Aqueous solution, that means what is the meaning of aqueous is nothing but H2O. The H2O means that in a solution H2O can be accessed as solvents. That's why it is known as the aqueous solutions. Aquaculture, like as a fish culture, like as all are having the H2O, aqua in a water bottle like this. Next, non-aqueous is nothing but the solution having no water, that is known as the non is nothing but always no, that is called as a H2O. Cannot be present in a non-aqueous solution. If the non-aqueous solution like as ether and alcohol and acetone, so remaining these all are can be acts as a solvent. That type of is known as a non-aqueous solutions. So that is called, these all are the organic compounds. All organic compounds are in a non-aqueous solvents, and that is a H2O can be acts as a polar solution. These are the non-polar solutions also because of having no polarity. So H2O having the H plus and OH minus, so it can be acts as a polar. So NaCl, Na plus Cl minus, so H2O Cl minus, Na plus OH, these are the attraction to each other can be easily solvable because of their polarity. So basing on their polarity, pole is nothing but opposite charges. Pole, north pole, south pole, opposite, like I say, positive and as a negative. That is called, the aqueous solutions are also known as polar solutions. The non-aqueous solutions are also known as non-polar solvents. Basing on their solvents, the solution can be defined as the aqueous solution and non-aqueous solutions. So next one. In our solution topic, ఈ సొల్యూషన్ టాపిక్ ని మన నేచర్ లో ఎంత ఈజీగా వాడతామో అనేది ఒక సింపుల్ ఎగ్జాంపుల్ మీకు కింద సింపుల్ గా చెప్తాను, జాగ్రత్తగా వినండి. సాల్యుబిలిటీలో వస్తుంది బట్ సింపుల్ వాటర్. జస్ట్ ఒక సొల్యూషన్ టాపిక్ అనేది నేచర్ లో ఒక పెద్ద బిగ్ సొల్యూషన్ ఎలా క్లియర్ చేయగలిగింది అనేది ఒక సింపుల్ ఎగ్జాంపుల్స్ తో చెప్తాను. సొల్యూషన్ టాపిక్ ఈజ్ అ వెరీ వెరీ యూస్ఫుల్ ఇన్ అవర్ డైలీ లైఫ్. బై సింపుల్ ఎగ్జాంపుల్, చిన్న టిప్స్ లాంటిది. ఇన్ అవర్ కూల్ కంట్రీస్, like as a land, like England or Switzerland or New Zealand. The name is ending with land. All countries are in the snow. All are some మంచు కంట్రీస్ అనమాట. అంటే మంచు ఎక్కువగా ఉండే ప్రాంతాలన్నింటినీ కూడా ఎండ్ అవుతా ఉంటాయి. ఇప్పుడు మనకి విశాఖపట్నం, మచిలీపట్నం, పట్నం అయితే ఎలాగైతే అన్ని ఎండింగ్ విత్ సముద్రాలతో ఉంటాయో, ఈ ల్యాండ్ అనే కనుక ఉంటే అవన్నీ కూడా ఎలా ఉంటాయి అంటే అన్ని కూడా మంచుతో కూడి ఉంటాయి. లైక్ స్విట్జర్లాండ్, ఇంగ్లాండ్, న్యూజిలాండ్ ఆల్ ఆర్ ద మంచు ఐస్ ప్రాంతాలు అనమాట. అయితే వీటన్నిటిలో కూడా ఎలా ఉంటుందంటే కార్లో ఖచ్చితంగా రెగ్యులేటర్లో మనం ఏం వాడతామంటే H2 అనేది రెగ్యులేటర్లో వాడతాం. బికాస్ ఆఫ్ ఇట్స్ కూలింగ్ ఏజెంట్ గా యాడ్ చేస్తాం. అయితే స్విట్జర్లాండ్ లో వీటన్నిటిలో ఏమైపోతుంది అంటే రెగ్యులేటర్లో వేసిన వాటర్ కంపల్సరీగా ఏమైపోతుంది, సో ఐస్ అయిపోతుంది. అంటే ఎప్పుడైతే ఐస్ అయిపోతుందో కార్ అనేది ఏమైపోతుంది అంటే ఇట్ ఈస్ నాట్ స్టార్టింగ్, అది స్టార్ట్ కాదు. ఎందుకంటే అలాంటి దాంట్లో వాటర్ ఉంది కాబట్టి. అంటే ఇప్పుడు ఒకవేళ ఏమవుతుంది, అలాంటి కంట్రీస్ లో ఖచ్చితంగా నువ్వు కార్ అనేది మూవ్ అవ్వాలి అంటే ఖచ్చితంగా అది రన్నింగ్ లోనే ఉండాలి. అంటే ఇంజన్ అనేది ఇప్పుడు ఆల్వేస్ 24/7 అది ఆన్ లో ఉంటూనే ఉండాలి. అలాంటప్పుడు ఏం చేస్తారంటే అలా ప్రతిసారి 24/7 అది ఆన్ లోనే ఉంటే ద లైఫ్ టైమ్ ఆఫ్ ది కార్ విల్ బి డిక్రీజెస్. సో ఇట్ కెన్ బి ఈజీలీ, ఇట్ ఈస్ నాట్ యూస్ఫుల్ ఫర్ ద లాంగ్ టైమ్. సో దట్స్ ఏం చేసి ఆ టైంలో ఏం చేశారంటే ఇప్పుడు ఈ వాటర్ అనేది వాటర్ గానే ఉండాలి కానీ ఐస్ అయిపోతుంది. ఇప్పుడు ఏం చేయాలనేది నాట్ ఓన్లీ డివైనింగ్ చాలా కంట్రీస్ లో పెద్ద ప్రాబ్లమ్ గా ఉన్నప్పుడు ఏం చేశారంటే ఐస్ అనేది 0 డిగ్రీ సెంటీగ్రేడ్ దగ్గర ఎలా కన్వర్ట్ వాటర్ అనేది 0 డిగ్రీ సెంటీగ్రేడ్ దగ్గర ఐస్ గా కన్వర్ట్ అయిపోతుంది. సో ఇప్పుడైతే స్విట్జర్లాండ్ వీటన్ని కంట్రీస్ లో టెంపరేచర్ ఇప్పుడు కూడా -20 డిగ్రీస్ అంతే ఉంటుంది, -20, -30 ఇలా ఉంటుంది. కాబట్టి ఇప్పుడు ఇలాంటి చోట ఈ కార్లు మనం వాడలేము. ఎందుకు వాడలేమంటే ఈ కండిషన్ లో వాటర్ ఏమైపోతుంది, ఐస్ గా కన్వర్ట్ అయిపోతుంది. ఐస్ గా కన్వర్ట్ అయిపోతే ఇప్పుడు ఈ పెద్ద ప్రాబ్లం నాట్ అమెరికాలో కూడా మంచు ప్రాంతాలు ఉన్నాయి. సో ఇలాంటి వాటన్నిటిలో ఇది పెద్ద ప్రాబ్లం మనం ఎలా సాల్వ్ చేయాలని వాళ్ళందరూ తలలు పట్టుకున్నప్పుడు ఏమొచ్చిందంటే సింపుల్ సొల్యూషన్, ఇథైల్ ఆల్కహాల్. ఇథైల్ ఆల్కహాల్ అనేది లిక్విడ్ స్టేట్ నుంచి సాలిడ్ స్టేట్ గా కన్వర్ట్ అవ్వాలి అంటే -125 డిగ్రీ సెంటిగ్రేడ్ కావాలి. అంటే ఏ నేచర్ లో కూడా ఇప్పటి వరకు ఏ నేచర్ లో కూడా న్యాచురల్ గా -125 డిగ్రీ సెంటిగ్రేడ్ ఎగ్జిస్ట్ కాలేదు అంటే ఖచ్చితంగా వాటర్ బదులు ఆల్కహాల్ యూజ్ చేస్తే ఖచ్చితంగా మన బైక్స్ నడపవచ్చు అంటున్నారు. బట్ కానీ వాటర్ తో పోల్చుకుంటే ఇథైల్ ఆల్కహాల్ సో ఎక్స్పెన్సివ్ అండ్ టు దట్ ఇథైల్ ఆల్కహాల్ ఇస్ అ హైలీ బర్నింగ్ కెపాసిటీ, హైలీ ఫ్లేమబుల్ కెపాసిటీ. సో లిటిల్ బిట్ హీట్ దగ్గర ఈజీగా ఫైర్ ని క్యాప్చర్ చేస్తుంది. అందుకని ఇథైల్ ఆల్కహాల్ ని వదిలేశారు. నెక్స్ట్ వన్ ఇప్పుడు ఏం చేయాలి మళ్ళీ అర్థం కాలేదు వాళ్ళకి. అందుకని ఏం చేశారంటే కాంబినేషన్ తో వాటర్ H2O ప్లస్ ఇథైల్ glycol. So that is called CH2OH. So this is the combination H2O plus ethylene glycol. So ethylene glycol ఈ రెండు కాంబినేషన్ తో వాడినప్పుడు ఏమైపోతుందంటే ఈ టెంపరేచర్ వాడడానికి -100 డిగ్రీ సెంటిగ్రేడ్ దగ్గర మాత్రమే ఏమైపోతుందంటే ఈ కాంబినేషన్ అనేది లిక్విడ్ అనేది సాలిడ్ గా కన్వర్ట్ అయిపోతుంది. సో అంటే ఏమవుతుంది నేచర్ లో ఇంతవరకు మనకు -100 డిగ్రీస్ కూడా లేదు. మాక్సిమం ఉంది కూడా -93 డిగ్రీ సెంటిగ్రేడ్, అది కూడా ఆర్కిటిక్ ప్లేస్ లో ఉంది, నాట్ అంటార్క్టికా. సో అందుకని ఏంటంటే ఇప్పుడున్న కార్ స్విట్జర్లాండ్ వీటిలో కాంబినేషన్ లో వాడుతూ ఉంటారు అనమాట. H2O ప్లస్ ఇథిలీన్ గ్లైకాల్. సో ఇథిలీన్ ఈ రెండింటిని కాంబినేషన్ లో వాడితే -100 డిగ్రీ సెంటిగ్రేడ్ ఉంటుంది. కాబట్టి ఇలాంటి కండిషన్ లో వాటర్ అనేది ఐస్ కానే కాదు. అందుకని ఏం చేస్తారంటే అలాంటి కంట్రీస్ అన్నింటిలో చూసారా ఒక పెద్ద ప్రాబ్లమ్ ని ప్రపంచం మొత్తం ఎదుర్కొన్న ఒక పెద్ద ప్రాబ్లమ్ ని ఒక సింపుల్ కాంపోనెంట్ ద సొల్యూషన్ టాపిక్ కెన్ బి ఈజీలీ క్లియర్ ఆల్ ద ప్రాబ్లమ్స్. సో దిస్ నాట్ ఓన్లీ దిస్ బికాస్ ఆఫ్ ద లాట్ ఆఫ్ ఎగ్జాంపుల్స్ కెన్ బి సాల్వ్ బై దీస్ సింపుల్ సొల్యూషన్స్. ఈ యొక్క పెద్ద ప్రాబ్లం కూడా ఒక చిన్న ఐడియాతోనే సాల్వ్ చేయొచ్చు. ఈ ఒక్క సొల్యూషన్ టాపిక్ అనేది మనం ఆడే డైలీ లైఫ్ లో ఎంత యూస్ఫుల్ అవుతుంది అనేది అంత యూస్ఫుల్ అవుతుంది. నాట్ ఓన్లీ లైక్ దిస్. ఇప్పుడు మనం ఆల్ గల్ఫ్ కంట్రీస్ నుంచి మన పెట్రోల్ ఎప్పుడు కూడా మనం ఇంపోర్ట్ చేసుకోం, ఎప్పుడు కూడా పెట్రోలియం ని ఇంపోర్ట్ చేసుకుంటాం. బికాస్ ఆఫ్ ది పెట్రోలియం ఈజ్ అ కాంబినేషన్ ఆఫ్ పెట్రోల్, డీజిల్, next one is a benzene, is a kerosene. So we have to take only one component, we have to take one solution. So based on this solution we have to using certain limits, certain methods. Already I have to say there's a crystallization, distillation, evaporation. By using this method, some different temperatures we have to separate like all these. So by using this petroleum we can use the like of all petroleum, diesel, benzene, kerosene like this. So this solution topic is a very very important subject, and it is not only the reading subject, it is applied to the daily life, so they can be it can be useful for to clarify all types of problems. So this is the one of the best applicable property. నేను మీకు ఇది ఒక applicable property మాత్రమే ఒకటి చెప్పాను. ఇదే కాదు ఇంకా చాలా చాలా ప్రాబ్లమ్స్ ఉన్నాయి, వాటన్నిటిని కూడా మనం చేసుకోవచ్చు ఈ సొల్యూషన్ టాపిక్స్. ఇదే కాదు ముందు మనం ఈ టాపిక్స్ మన డెప్త్ లో కనుక వెళ్ళినట్లయితే అన్ని చెప్పొచ్చు. సీ డైవర్స్ కానీ సీ డైవర్స్కి వెళ్ళే వాళ్ళు ఎవరెస్ట్ ఎక్కేటప్పుడు కూడా మాక్సిమం సింపుల్ టాపిక్ చెప్తాను. జస్ట్ ఇప్పుడు యాక్చువల్గా మనకు కావాలంటే నాట్ ఓన్లీ ఆక్సిజన్, మనకి బతకాలంటే ఒక O2నే సరిపోదు, CO2 కూడా కావాలి. CO2 కూడా ఎందుకు కావాలి అంటే మన బాడీలో CO2 అనేది H2Oతో రియాక్ట్ అయిపోయి H2CO3 అనేది మనకి ఫామ్ అవుతుంది. దట్ H2CO3 ఈజ్ నోన్ యాజ్ ద కార్బోనిక్ యాసిడ్. This carbonic acid can be useful for the to stimulation of the blood pH of the blood well, pH of the blood. So next, by using this that mixture in O2 plus CO2 combination in hospitality, the patient also can be used as the CO2 plus CO2, that is called a 95%, and it is the 5%. That mixture is known as the carbogen. So that is known as the gas in a gas. That is also one of the types of the solution. One of the types of the solution is the carbogen gas. This carbogen mixture can be helpful for the in our blood pH value will be stimulated and the maintain can be each other. Not only in this. Next, in Everest we have to go to the high altitude, so there is no oxygen level. Then in our body the pressure will be higher than the atmosphere. The pressure can be came out from the higher pressure to low pressure. That pressure can be moved from our body to nature through the form of the blood. So that's why you can use in Everest we have some masks and we can use some oxygen mask tanks like this, and we have to use the sea divers also use some of the gases mixtures, O2 plus N2 mixtures, and like this some of the inert gas like I say helium also, because of their our body condition, our temperature conditions will be stimulate each other in sea divers. So this is also one of the gas in a component. So మనకున్నటువంటి ఈ సొల్యూషన్ టాపిక్స్ మన నేచర్ మనం ఎలా బతకడానికి నేచర్ లో ఒక్కొక్కదానికి ఒక్కొక్క ప్రాపర్టీ ఒక్కొక్క సొల్యూషన్ ఒక్కొక్క ప్రాబ్లమ్ ఎలా సాల్వ్ చేయడానికి ఇవన్నీ కూడా వాడతాం. బట్ ఇవన్నీ కూడా ఇటన్ని కండిషన్స్ లో అన్ని ఆక్సిజన్ కెన్ బి యాక్ట్ యాజ్ ఏ సాల్వెంట్, రిమైనింగ్ ఆల్ ఆర్ కెన్ బి యాక్ట్ యాజ్ ఏ solutes because of this lesser quantity. But in a space we can use 100% of the O2 oxygen. మనకి స్పేస్ లో మాత్రం మనకి CO2 అవసరం లేదు, N2 అవసరం లేదు, ఏమీ అవసరం లేదు, 100% ఓన్లీ ప్యూర్ ఆక్సిజన్ మాత్రమే వాడతాము. సో దిస్ ఇస్ ద one of the different types of the gases in our daily life. So this is the so this is the types of solutions and definition of the solution. What is the definition of the solution? Is nothing but the homogeneous mixture of two or more components whose component can be vary within certain limits is known as a solution. That is known as the true solution. So small break, I will back each.
విద్యార్థుల భవిష్యత్తుకు బాటలు వేస్తూ మునుపెన్నడూ ఎరుగని అత్యుత్తమమైన ఫలితాలతో అద్భుతమైన విద్యా ప్రమాణాలతో ముందుకు దూసుకుపోతోంది శ్రద్ధ జూనియర్ కళాశాల. మహబూబ్నగర్ జిల్లా కేంద్రంలో ప్రముఖులు అనుభవజ్ఞులైన చైర్మన్ జగపతిరావు ఆధ్వర్యంలో 2011లో స్థాపించబడిన మా శ్రద్ధ జూనియర్ కళాశాల ఉన్నతమైన విద్యా ప్రమాణాలతో ఇంజనీరింగ్, మెడికల్లో చక్కని ర్యాంకుల సాధనలో విజయం వైపుగా కృషి చేస్తోంది. ఇంజనీరింగ్ అయినా మెడికల్ అయినా శ్రద్ధ జూనియర్ కళాశాల విద్యార్థులదే పై చేయి. ఇంటర్ తో పాటు ఐఐటి, నీట్, ఎంసెట్ నందు లాంగ్ టర్మ్ ప్రోగ్రామ్స్ ద్వారా కార్పొరేట్ కళాశాలలో 20 సంవత్సరాల అనుభవం కలిగిన అధ్యాపక బృందంచే ప్రత్యేక శిక్షణ తరగతులు నిర్వహిస్తూ డైలీ ప్రాక్టీస్ పేపర్స్, వీక్లీ టెస్ట్, కౌన్సిలింగ్ ద్వారా విద్యార్థుల నైపుణ్యం మెరుగుపరచడం మా ప్రత్యేకత. హ్యాండ్బాల్, ఫుట్బాల్, క్రికెట్ లో మా విద్యార్థులు జాతీయ క్రీడాకారులుగా గుర్తింపు పొందుతున్నారు. జిల్లా కేంద్రంలో సొంత భవనాలలో కళాశాలలు, విద్యార్థులకు ఉదయం సాయంత్రం వేళలో స్టడీ అవర్స్, ఐఐటి, నీట్ లో ప్రముఖుల నిపుణులచే విద్యా బోధన, బాలికల కోసం ప్రత్యేక క్యాంపస్, ఎంపీసీ, బైపీసీ గ్రూప్లతో కో ఎడ్యుకేషన్, ఎంపీసీ, బైపీసీ, ఎంఈసీ, సిఈసీ గ్రూప్లతో గర్ల్స్ క్యాంపస్, ఎంపీసీ, బైపీసీ గ్రూప్లతో పాటు ఐఐటి, నీట్, ఎంసెట్లతో అకాడమీ.
I am Mariam Makbool. I passed out from SHRADDHA Junior College in 2017 from BPC. Currently, I have passed out from Tata Institute of Social Sciences. I finished my bachelor's. So one thing which is very striking about this institute is the immense and genuine amount of effort that the team of faculty puts and takes up for the success of students and their prosperity. And another thing that is very remarkable about this place is they ignited in me the spirit of competitiveness, which is very necessary in this globally evolving market world. There was one Sanskrit slok which I learnt when I was very young. Udhyame nahi siddhyanti karyani na manorataihi nahi suptasya simhasya pravishanti mukhe mruga. This means you cannot just achieve anything just by thinking of it. You need to put in effort. That is what I have learnt from this institute. Like, even though lion is king of jungle, it has to hunt for its own prey, which is what I have learnt from SHRADDHA Junior College.
I am Uday Kiran. I have completed my intermediate in SHRADDHA Junior College in 2019, and I have joined Srinath Institute of Science and Technology, and I scored my JEE Mains percentile as 98.19, and due to some other problems I didn't join NIT, and I have scored my MCET rank as 4500. And here the lecturers take the special care with each and every student.
సీనియర్ మరియు జూనియర్ ఇంటర్ అడ్మిషన్ల కోసం సంప్రదించవలసిన మా చిరునామా శ్రద్ధ జూనియర్ కళాశాల కో ఎడ్యుకేషన్ క్యాంపస్ మెట్టుగడ్డ. మీరు సంప్రదించవలసిన మా ఫోన్ నెంబర్ 9494430200. ప్రత్యేకమైన గర్ల్స్ క్యాంపస్ కోసం సంప్రదించవలసిన మా చిరునామా ఆపోజిట్ పంచవటి హోటల్, న్యూ టౌన్, మహబూబ్ నగర్. మా ఫోన్ నెంబర్ 7337294653. ఐఐటి నీట్ అకాడమీ కోసం సంప్రదించవలసిన మా చిరునామా శ్రద్ధ జూనియర్ కళాశాల మెట్టుగడ్డ. మా ఫోన్ నెంబర్ 9491629962.
Right. Now we are clear about that. Already in the previous the definition of the solution and the different types of the solutions. The different types of the solution is nothing but is the basing of the solvent is like I say aqueous solution and a non-aqueous solution. So aqueous solution is the solution having the water, like I said, the water can be acted as a solvent, so that is known as the aqueous solutions. In a non-aqueous solutions, the water cannot be used as like I said, alcohol and ether and acetones can be used as a solvent, so that is known as the non-aqueous solutions. The non-aqueous solution is nothing but the no water. Non-aqueous is no water. So basing on their physical state, we can use the different types of the solutions, like as a gas in a gas, liquids in a liquids, and solid in a solid. The solid in a solid can be used as a brass, bronze, gold, is a rolled gold, and a different types of alloys. The all alloys can be used. All alloys can be one of solids in a solids phase. Like as a solids in a solids means one of the dispersed phase. Another one is a dispersion medium. Dispersed phase is a DP. DP is equal to solute. So DM, that is called dispersion medium. It is known as the solvent. So that is called based on their physical state. We can use different types of solutions. Next, liquids in a liquids, like as a milk. In a milk, so it is a 15% of the milk and remaining 85% of the water. That is known as the liquids in a liquids, and also use an alcohol and water. Next one is a gas in a gas phase. That is called as the air. In air, atmosphere, then in 78% of the nitrogen and remaining oxygen is the remaining, all are the solvents, can be acted as a solvents. Next, basing on their physical state, different types of these solutions. Next one, we have to go through the another topics, another concept that is known as the solutions of the different solution, like I say saturated solution. Saturated solution. Next one is the dilute solutions. Next one, concentration solution. concentration solution. What is the known as the saturated solution is nothing but that is known as the known solution. Best example is the standard condition, is the standard temperature. The standard temperature is nothing but 25. That is called as a fixed value. That is a unique value. That is the standard solution is known as the known solution is known as the standard solutions. Next one, dilute solution is nothing but in a solution having small quantity of solute is known as dilute solutions. Next one is a concentration solution is nothing but solution having large quantity of solute, that is known as concentration solution. Take one example like concentrated HCl versus is a diluted HCl. What is the concentration of the solution is nothing but in a solution having the concentration can be used as a large quantity. If we can add the large number of water molecules, it can be easily converted into the dilute. So in this dilute solution, in a solution having the small quantity, that is known as the dilute solution. In a concentration solution is nothing but the solute quantity is large. In a concentration solution we can add to the large number of water molecules. So we can add the water, it can be converted into the dilute. So in this dilute solution the quantity of the solute must be decreases and it is converted into the concentrated to dilute solution. So this is the different types of the saturated and dilute and concentrate. Weight percentage is nothing but the ratio of weight of the solute by weight of solute and weight of solvent per cent, that is known as the 100%, that is known as the weight of solution. So take one of the example is nothing but take CO2. In a CO2, so in a composition CO2 gas, so what is the percentage of the carbon? What is the percentage of the carbon is nothing but it's equal to weight of carbon by weight of carbon plus weight of oxygen into 100. That is equal weight of carbon is equal to 12 by 12 plus 1 oxygen is equal, 1 oxygen is a 16, 2 oxygen is a 32, that into 100, that is equal 12 by 44 into 100, that is approximate value, that is equal to, so that is a 27%, that is equal to what is the percentage of the carbon. So that is a one of the percentage. Next one, volume percentage is nothing but the ratio of weight of the volume of the solute to volume of the solution in 100 ml of the water, 100 ml of the solution is known as the volume percentage. That is equal to weight percentage is equal to volume of the solute by volume of the solution into 100, that is equal to, that is known as the volume percentage, that is the weight percentage, and this is the volume percentage. Next one is a weight by volume percentage is nothing but weight by volume is nothing but weight of the solute by volume of the solution. So that is a difference between the weight and volume, and basing on their both weight and volume is weight and volume percentage. Next, ppm. So by ppm is nothing but parts per million. Parts per million is nothing but weight of the solute by weight of the solution into parts per million is nothing but 10 to the power of 6. This parts per million can be used for the testing of the water by using according to TDS, total dissolving solids in our Bisleri water or Kinley water, the ppm value, the TDS value is approximately, according to WHO, the 300 ppm value must be a drinking purpose, is a very healthy good for the ppm. But in according to our Indians, so ISI, so the TDS value is according to 50 to 100 value, that is the good for health water, that is the ppm. This ppm can be useful for the basing on their TDS, total dissolving solids. How much number of solids are dissolved in the particular solutions? So it can be easily find this water can be easily drinking purpose, as the waste purpose, or a drainage purpose. It is a pollution of the water pollution. If the highest TDS value, it is not useful for the sufficient for the drinking of the water. So that is a different expression method. This is the basic methods for we have to find the concentration of the solution, like as a solute and a solvent, like as a carbon, not only different types of methods for the solute and solvent methods. Next, not only these are the basic concepts. Next, we have to go very important concepts for the expression of the methods for the concentration of the solution. Concentrate, that is called, already we know that in a first class basic concepts in stoichiometry, molarity, that can be denoted as a capital M, normality, next one mole fraction, small m, it can be denoted as a small m. Next one mole fraction, that is called X. Molality, that is called as a small m. Next one is a formality, but formality is not, it is a similarity to the molarity, so can ignore like this. Next, molarity. So the molarity is nothing but we can easily define as the number of moles of solute, dissolved in number of moles of solute dissolved in a 1,000 ml, 1 liter of this solution. 1 liter of this solution is known as molarity, number of moles of solute. Number of moles of solute dissolved in 1 liter of this solution. 1 liter. So it can be denoted as M is equal to N by V into 1000 in ml, if ml is converted into. So that is called molarity. Number of moles of solute is dissolved in 1 liter of this solution is known as molarity. Next is another formula, molarity, then is density is equal to mass by volume, that is equal to, according to Charles' law, V is proportional to T. So molarity is depends on temperature. If the molarity is increases, temperature is decreases. Because of the volume is directly proportional to T, so then molarity is inversely proportional to the T. Because of the volume is directly proportional to T, like this. So the molarity is depends on temperature. If the molarity is increases, then the temperature is decreases. Next one. So we have to take another formula of the elaborate like this. Number of N is equal to, formula is a weight by molecular weight or gram molecular weight. Weight by gram molecular weight. N is equal to, we have to substitute like this, weight by molecular weight into 1000 by V in ml. V in ml. So this is the one of the formula to find the molarity, how much amount of the solute is present in a 1 liter of this solution. We can easily find out the molarity of the solute. Next one, we have another formula. Next, molecular weight, molarity. Next one, in a dilute solution. In a dilute solution, molarity of the one component in a volume of the solution is equal to molarity of the another solvent in a volume of the another component. That is called dilution law. So M1 V1 is equal to M2 V2. Different components we have to take. If the components are diluted along with water, so that is called formula M1 V1 is equal to M2 into X plus V2. So that is equal to X is equal to V2 minus V1. So this is one of the basic important formula, is a dilution solution with water. So this is the formula for the not only water, so we have to use another solvents like as a non-aqueous or alcohol, like this, whatever it may be. So this is the dilute for the molarity. So molarity is the number of moles of solute is present in 1 liter of this solution is known as the molarity. So this the formula can be elaborated like this. So next, molarity. Next one, this is a basic important. We have to lot of number of formulas here. Then we have to go to the in a deep concept. Then we have to explain clarity. Clear. So normality. So normality is nothing but the number of, normality is a capital N, the number of, that is the number of moles. Difference between the molarity and the normality. The number of moles, but here is the number of moles is not, is the number of milli equivalents. The number of milli equivalents present in 1 liter of this solution is known as the normality. So molarity and normality is difference in nothing but here we take N is the number of moles, but here take this the number of milli equivalents. The milli equivalents is different than the number of moles. So they have to explain like this. So normality is equal to N is equal to weight by gram equivalent weight. Here we take the molecular weight and we take the gram equivalent weight into 1 by V in liter, that is equal to weight by gram equivalent weight into 1000 by V in ml. That is called, what is the difference between the molarity and the normality is nothing but in a molarity we have to take is the number of moles, but in a normality we have to take is the gram equivalent weight. So gram, what is the difference between the molecular weight and the gram equivalent weight is nothing but, so it's a very very important concept because it can be easily differentiate the molarity and normality. Molarity, normality in easy find out. Next, M versus N. So M is equal to weight by gram molecular weight into 1000 by V in ml. Normality is equal to weight by equivalent weight into 1000 by V in ml. 1000 by V in ml. So you have to carry difference between the gram equivalent and gram molecular weight and gram equivalent weight. So if I take for an example gram molecular weight versus equivalent weight. Gram molecular weight is nothing but molecule. Molecule is a combination of atoms. Like example O2, that is called a combination of 2 atoms, oxygen plus oxygen. Oxygen weight is 16 and it is the oxygen weight is 16. So the combination of atoms is known as a molecule. The combination of atomic weights to form a molecular weight, that is called, that molecular weight can be expressed in grams, that is known as the gram molecular weight. So that is called 16 plus 16, that is equal to 32, that is called molecular weight. That molecular weight can be represented in grams, that is known as the gram molecular weight. Next one, we take the gram equivalent weight. So the equivalent weight we have to use some different formulas. Molecular weight of the for atoms, next one for molecules, that molecules having both acids, bases and salts, and here it is a different oxidizing agents and reducing agents and like this different types. According for atoms equivalent weight is equal to atomic weight by valency or n factor. N factor is nothing but is a valency or what, or acidity or base, it is like this, whatever. Say take aluminium, equivalent weight of, take one example, equivalent weight of aluminium is equal to atomic weight of aluminium by valency. Atomic weight of aluminium is equal to 27. The valency of aluminium is 3. How, what is the, it is a 3, nothing but equivalent weight is 9, but atomic weight aluminium is equal to 27. Atomic weight is at 27, equivalent weight of aluminium is 9. So equivalent weight is equal to atomic weight by valency, that is called n factor. What is the valence of the aluminium is 3. How can you define? Is nothing but, so it's a basic concept. Aluminium is atomic number 13, so it can be written as neon 3s2 3p1. 3s2 3p1. All elements are except inert gases, remaining all elements are in a combined state due to the stability. According to basing on their stability in inorganic concept, octet rule. So in outermost electronic configuration in an atom, outermost electrons are 8 electrons in outermost, so it is a stable. So 1s2 2s2 2p6 3s2 3p1, so it can be like this as shells 1s2, next 2s2 2p6 3s2 3p1. So if aluminum get the 5 electrons is a gain, so to get the 8 electrons in outermost, so it can be easily stable. Other chances, if the electrons, so 3 electrons are loose, so it can be 8 electrons in outermost, that is the 2s2 2p6, so that is the 8 electrons, so it can be easily. So 5 electrons are gained is very difficult to, and 3 electrons are lost is very easily, so that's why the aluminum can be easily lose the 3 electrons. The loss of electrons, that can be defined as the valency. Loss of electrons or gain of electrons or sharing of electrons, all these definitions can be used by using valency or combining capacity. Combining capacity of an element is known as the valency. That aluminum has loss of 3 electrons from the outermost orbit, so it can be easily get the 8 electrons from the 8 electrons of the 2s2 2p6 can be easily stable. So that is the valency of the aluminum is 3. If you can take the another example, sodium. So sodium equivalent atomic weight and equivalent weight. Sodium is atomic weight is 13. Equivalent weight of the sodium is equal to atomic weight by valency. In a sodium, outermost electron configuration is 3s neon 3s1. Outermost electron is the loss of 3s1 electron. To get a neon configuration, it can be easily stable. So in a sodium atom, loss of single electron. So the loss of electrons is nothing but single electron. That electron can be behaves as a valency. So that is a 13 by valency is 1 because of it loss of only 1 electron, that can be accessed as a valency, that is called 13. This 13 is known as the equivalent weight. Sometimes some of the elements can be exist both the atomic weights and the equivalents can be same. Both sodium is a 13 atomic weight and equivalent weight is also 13. So that is the equivalent for the atoms and molecules like as acids and bases and salts. So these are the different types. So equivalent weight of the atoms already is over. We have to go to the molecules of the equivalent weight. So this equivalent weight is a very important and basic concept for to solve the all problems of the normality and molarity. So it can be useful for the difference between the molarity and normality problems also, and also it is helpful for the stoichiometric topic. Next, go to the equivalent weight for the molecules. Equivalent weight for the molecules, so already it is over for the atoms. Next, go to the molecules. For molecules, how to find out the equivalent weight and molecular weight. So for molecules taken as acids, best example, same atomic weight as equivalent weight. For atomic weight taken as a HCl, already molecular weight, already say that molecules is nothing but combination of atoms. The molecular weight is nothing but the combination of atomic weights is known as the molecular weight. So HCl is not an atom, it is a molecule. The combination of H plus Cl minus molecular weight, hydrogen is a 1, chlorine is 35.5, that is equal to 36.5. So the molecular weight of the HCl is 36.5. For what about the equivalent weight of the HCl is nothing but equivalent weight of HCl is equal to same molecular weight by same factor is the n factor. For atoms, n factor can be taken as a valency. For acids, equivalent weight can be taken as a n factor. For acids, n factor is nothing but is the basicity. Basicity is nothing but number of H plus ions released from acids. best example. For HCl, H plus Cl minus, how many number of H plus is releases? Only one, that is called n factor is 1. So that is called equivalent weight is equal to molecular weight by n factor. That is called molecular weight is equal to 36.5, n factor is equal to 1. So that is a n factor 1, that is equal to 36.5. I'm already said that so molecular atomic weights and equivalent weights will be equal sum of the atoms, like as a sodium. Next, similarly HCl having the atom molecular weight is equal to 36.5 and same time equivalent weight is equal to 36.5. For HCl both atomic molecular weights and equivalent weights are the same factor, but it is a very important concept for the remaining acids. It's a very important. We have to for different types of H plus ions. Take for oxyacids, HNO3, H2SO4, H3PO4, H3PO3. Next one, H2. We have lot of number of oxyacids. Then what is the importance of the equivalent weight? We have to find is very important for HNO3 is the cleavage as H plus NO3 minus. So here is the number of H plus ions are releasing is 1, that is equal to n factor is 1. So how to find out the number of H plus ions? It's a very important for oxyacids. We have to formula for oxyacids having one OH bond and one double bond O group. Oxygen is a double bond O group. For oxyacids, the acids compulsory one OH bond and double bond O group. So that is called the key to like this. HNO3 we have to like this, N double bond O, like as a one double bond O group and one OH group. That is called, so for oxyacid, that is the for rule. That is the we have to easily find out the number of H plus ions from the compound. So we have to observe like this. HNO, because of remaining one oxygen is there, that is called coordinate covalent bond like this. So that is called number of H plus ions. So the OH minus the OH can be easily give the one H plus. So that's why the number of H plus ions is only 1. That is called n factor is 1. For H2SO4, this is also one of the oxyacid. Oxyacid is nothing but oxygen and hydrogen combination is known as the oxyacids. Next one for H2SO4, for oxyacids having the one OH group and one OH group or double OH bond and one double bond O group. For H2SO4, yes, one double bond O group. Next one OH group. In the remaining is a one O group, one H and two O. So remaining in one OH, two O can write as a one OH. And again has the one oxygen. So that is can be written as the double bond O. So in this molecule, two number of hydrogen molecules there, that is called N is equal to 2. So we have to find. So N factor for the sulfuric acid is N is equal to 2 because of the sulfuric acid having the 2 H plus ions from the OH group along with H3PO4. So P double bond O, one OH group. Remaining we have to distribute like this. So 2 H and 2 O like this. OH and OH. So in this phosphoric acid, that is also orthophosphoric acid having three OH bonds. These three OH bonds can be easily give 3 hydrogens. That is called N factor is equal to 3. But in the H3PO3, but the N value is not equal to 3 because of the structure is like as a P double bond O group and POH. So POH, remaining 2 only one oxygen can be written as the OH and one remaining one is the hydrogen H3 PO3. So in this molecule only N value is the 2 because of 2 OH bonds only. So 2 OH bonds can be give the 2 hydrogens, that is the N factor is 2, not a 3. Because of this hydrogen is this hydrogen can be as a reducing agent. The large number of hydrogens it can be acted as a West reducing agents. Anyway, thank you. In tomorrow classes we have to find the equivalent weight of the all acids and bases and remaining oxidizing agents and reducing agents of the by using N factor. So anyway, thank you.
విద్యార్థుల భవిష్యత్తుకు బాటలు వేస్తూ మునుపెన్నడూ ఎరుగని అత్యుత్తమమైన ఫలితాలతో అద్భుతమైన విద్యా ప్రమాణాలతో ముందుకు దూసుకుపోతోంది శ్రద్ధ జూనియర్ కళాశాల. మహబూబ్నగర్ జిల్లా కేంద్రంలో ప్రముఖులు అనుభవజ్ఞులైన చైర్మన్ జగపతిరావు ఆధ్వర్యంలో 2011లో స్థాపించబడిన మా శ్రద్ధ జూనియర్ కళాశాల ఉన్నతమైన విద్యా ప్రమాణాలతో ఇంజనీరింగ్, మెడికల్లో చక్కని ర్యాంకుల సాధనలో విజయం వైపుగా కృషి చేస్తోంది. ఇంజనీరింగ్